everyone, welcome back to my YouTube channel. Again, my name is Exp1 from ECE41 of the Electronics Engineering Department of the De La Salle University das Marinas. We're fourth year already, and for our YouTube playlist today, we will be having our robotics laboratory episodes, which will primarily focus on our exploration of the Arduino Uno, Arduino Uno microcontroller, as well as the programming languages that we will be using to program electronic components. But for now, we will be focusing on the experiment 1 or the laboratory activity number 1 entitled DC Motor Control with Computer and Microcontroller Interfacing. So with our guide and instructor, Engineer Jacqueline Verduca. So for our experiment number 1 objectives, the experiment will enable students to control the direction of rotation of a DC motor using an H-bridge circuit. Second is to control the speed of rotation of a DC motor using PWM or pulse width modulation. Third one, of course, is to create an Arduino programming or to construct our own code to control the DC motor, which is the goal of the experiment. And next one is to create a computer program user interface to send data control to our Arduino microcontroller. So the equipments and materials that we will be needed for the experiment number 1 is, of course, our personal computer, our Arduino microcontroller, which is this picture shown on your right side, and then our conveyor system, our L293D motor driver, okay, this is an IC, our power supply, of course, 5 volts and 9 volts power supply will be best for this experiment. We will also use breadboard, alligator clips, and connecting wires. But these equipments and materials can be optional because we can actually simulate the experiment using the TinkerCad that we will be explaining later on as we go on to the experiment paper. So as our introduction, we will be controlling the speed of the motor as well as the rotation's direction using the programming codes that we will be constructing in our TinkerCad later on. So we will be using this code, which will be effective using the help of our Arduino Uno, which will relay the message to our electronic components, specifically the motor, so that we will be able to control its speed and its rotation direction, meaning it could be counterclockwise or clockwise, or it can stop. Okay, so we will be explaining it later on. So our L293D IC will be our motor driver. So this is really important, and we will be needing a DC motor. Okay, so it's not an AC motor but a direct current motor. So with that introduction, let's proceed with our procedures. So if you have your own instruments, okay, your own electronic components, we can actually imitate this setup wherein we have the computer on our computer with us and our electronic components in our side. Okay, so for the procedure number 2, we have to connect the DC motor to the power amplifier IC as shown below on our schematic diagram. So with this, we'll be showing you how we will be connecting it using our fritzing software. So you just have to follow this schematic, okay, taking in high consideration the specific number of pins where the motor is connected as well as the power supply. Okay, so showing you how we can connect this using our fritzing software. Let's go to our fritzing here. If you want to create a new file, just create file and then new. Okay, but this time I already created my fritzing file. Okay, so here we use a breadboard. So if you want to use a breadboard, just type here. Okay, just search here your just search here your breadboard. Okay, just type there your breadboard, and everything will be showing. Every kind of breadboard will be showing already. So you have to familiarize with the electronic components, and I'll assume that you already familiarized with that. So we'll be using a breadboard, the L293D IC here. Okay, so take note. You have to take note of the notch of the IC. When you say notch, it's the indicator of the number of the pin of the IC. Okay, so from the notch and from this block circle here, you have to remember that the countings, of the number of pin will be here starting from the notch. So this is 1, okay, Wait, so this is 1, 2, 3, up to 8. Okay, 2, 4, 6, up to 8. And then this will be our 9. Okay, this will be our 9th pin. And if you want to familiarize with the fritzing, all you have to do is just pinpoint some of the IC's pin, and you'll be able to know the specific name of that pin. So the pin 1 will be for our enable one, and then pin 2 will be, okay, pin 2 will be for our input one. Okay, so just try to explore in order to understand the pins of the specific IC that we are using for the experiment. And then, okay, and then we will be using a DC motor here. All you have to do is just search it here. Okay, search DC motor here. You should use a direct current motor, not an AC motor, because that's the requirement of the experiment number 1. Okay, so I guess this is the DC motor. Just drag it here, okay, since I've already have one here. So all I have to do is just delete it. And we will also be using Arduino, okay, Arduino Uno. So all you have to do is just search it here, Arduino Uno. Okay, so if you want to know the name, okay, to know the name of the component, just click it. Then the name will appear here on the lower right corner of our screen. Okay, so we'll be using an Arduino Uno. So drag it here. I already have one, so I'll be deleting this one. And then we'll be using a 9-volt battery. So all you have to do is just search for 9 volts. Okay, I mean battery. Okay, wait. All you have to do is just search for battery. Okay, so everything will appear. And we will be using a 9 volts here. So BC 9 volts PC. So this one. Okay, so that's our 9 volts battery. So that's all of those are the components that we'll be needing for experiment 1. So taking note of the schematic here, you just have to follow in order to connect properly the components using wires. So based on our schematic diagram, we have to connect the DC motor, okay, DC motor to our power amplifier, which is our motor driver, which is the IC here. So based on the schematic, the motor is connected to the pin number 3 and pin number 6 of our IC. Okay, so one connection of the motor will be on pin number 3, so 1, 2, 3, and then the other one will be on pin number 6. So if you want to change if you want to connect, okay, if you want to connect the components, all you have to do is just search for wire, okay? Or, yeah, you can search for wire, and then if you want to change the color of the connection, you can actually edit it using our fritzing here, okay? In order for you to not be confused with the connection, because different colors of wires will be helpful, okay, to identify the proper connection of our circuit. So the blue wire will be for our DC motor. And based on the schematic, we're done with the DC motor. Let's connect, okay? If you can see here, it's quite small, but if you can see, the 9 volts battery, okay, the 9 volts battery is connected to our VS, okay? For us to be able to properly connect the components in accordance to our IC, we have here the pin configuration. This is a great help for you to familiarize with the right number of pins of the motor driver or the IC that we are using for this experiment. So for our 9 volts, as you can see on the schematic, it is connected to our VS. So the positive polarity here, which is connected using the red line, okay, same with our typical battery in actual applications, it is connected to our pin number 8, which is our pin for VS connection, okay? Take note of that. So we also have to ground the 9 volts battery, of course, because the circuit will not work if it's not properly grounded. So we have to just choose between 13 or 12 because it's the pin for our ground connection. So in my case, I've connected it in our 9, 10, 11, 12, in our 12 pin of the IC. So next connection is that next connection is our 5 volts power supply, which is directly given by our Arduino microcontroller. So if we will be connecting this in our 5 volts voltage supply, okay, it will give a 5 voltage output. So this 5 volts is connected to our BSS, which is on our 16th pin of the IC. So the red here, okay, the red here on our Arduino, which is, okay, you can see there, okay, you can see here if it's not covered with wire, it says 5 volts, okay? So the 5 volts will be connected to our 16th pin of the IC. So that's our BSS. So next is the proper grounding of the Arduino. So the ground of the Arduino here shall be connected to our 13th pin, since we already connected the ground of the 9 volts to our 12th pin. So our Arduino is properly connected already and grounded, as well as the 9 volts. So let's have the next connection from this schematic, which is, as you can see here, it's quite small, but the pin number 1 of the IC, okay, so this is the enable 1 pin. Okay, this name, enable 1 is connected using this green line to our pin number 9 of the Arduino microcontroller. Okay, as you can see here, because that will be our V logic on the pin number 1. So you can also connect it in other pins of the Arduino microcontroller. You can connect the V logic to any pins of the Arduino. Okay, then we will be having the input 1 of the motor driver. Okay, so this input 1 will be connected to our pin number 4 of the IC. As you can see, as you can see here, okay, pin number 4 is connected to our pin number 2 of the IC. The next one will be our input 2, okay, that will be our input 2. So our input 2 will be connected to our pin number 5 of the Arduino microcontroller as seen on our schematic. So it is here, this one, okay, this one. So pin number 2 and pin number 7 is connected to 5 and 4. So let's have the next one. So to explain, the input from the Arduino, which is connected to our IC, to the 4 and to the pin number 2 and 7, will be our input for the output, okay, for the output, which is our DC motor. So that's why we've connected here output 1, one connection for the DC motor, and then the next one will be our output 2. Okay, so that's the connection for our freezing and for our circuit. So now we will be having the schematic. So for our schematic, so if you'll be having this breadboard and to get the schematic, all you have to do is just click it here. So my schematic is already fixed, okay, because I've already properly laid out the wires. But if you're going to do it first time, the wires will not be properly placed. So your task is to fix the connection of the wires and to make it, let's say, a clear layout or a presentable layout wherein wires will not be interlapping each other. Okay, so as engineers, that's our goal, to make the schematic presentable and neat. So this is the schematic, okay, in accordance to the connection of our electronic components on our breadboard. So now we will be proceeding with our TinkerCad. So one last technique is that you can actually just fix the schematic by dragging the wires. You can drag it, okay? You can drag the wires. You can also drag the components. You can move the components in accordance to your preference and to your own design. So that's the style, okay? Just move it to make your schematic neat. So let's have the programming with our TinkerCad simulations. So now, after constructing our circuit, okay, and our schematic, we'll be having the circuit assembly using the TinkerCad. If you have the actual instruments and electronic components, it will be great, okay? You can actually have the circuit assembly in actual. So in our TinkerCad, you just have to make your own account, okay? I've already created mine, and just go to your circuits. So I've already created my own circuit. So this one. So all you have to do is just click this one, tinker this, okay? All you have to do is just click that one, tinker this, and then wait for it to load up. Okay, so here you'll be tasked to assemble the circuit once again in accordance to how you assembled it using your fritzing. Okay, so just follow your fritzing layout, repeat it here, and we'll be starting to code. Okay, so you just have to search for the components here. Okay, battery, so 9 volts battery, and then connect the components again. So we're going to create the code already. So in order to understand how can we code, okay, how can we code with our TinkerCad, we have to understand our task that we need to do. So for the first one, we have to create a program that will control the direction of the motor by sending character message to the microcontroller. When we say character, we can send character A, which will make the motor rotate clockwise. Okay, that's the first task. And then send character B, we will make the motor rotate counterclockwise. Okay, and then when we send character C, okay, you have to take note of the capitalization of the letter. It will cause the motor to stop. Okay, so going back to our TinkerCad, okay, wait a moment. Going back to our TinkerCad, I've already created the code here. Okay, this code is for our part A. Okay, so explaining our code, we will define the pins for our code. Okay, so we define pin number 9. Okay, so we also define the pin number 4 as well as pin number 5 as our inputs. So we also have this int value, which is for the motor speed. And then for the next one, we set the pins. Okay, we set the pins using this pin mode code as our outputs. So pin 1, 2, and 7. Okay, let me move it here to see it clearly. Pin number 1. Okay, pin number 1, 2, and 7 will be our outputs. So pin number 1 is for the V logic, and then pin number 2. Okay, pin number 2 will be for our pin number 2 and 7 is connected to our Arduino microcontroller. So that's the one that will process the information. And then this one, this serial begin 9600. Okay, so I forgot to put a comment. Okay, this serial begin 9600 is used to initialize the serial monitor, meaning it will activate our serial monitor. The next one, this digital write will be assigning the motor direction, if it will be rotating clockwise or counterclockwise, just like what is stated on our task. Then on this portion, we'll be having the actual program. Okay, so here we declare the values for motor rotation speed. Okay, using these values, this will determine our rotation speed. And then this one, serial available. Okay, under this one. Okay, so for our next code, we'll be having here string. So this is for the string character because we'll be treating a string data. So we'll be having string here. Okay, we'll be reading the string characters here using this code, and then we have to refer to the ASCII character value. So if you'll be searching on Google, let's search on Google. Okay, ASCII character values are programming language that is used by Americans. Okay, let's search here. Okay, if you'll be searching ASCII value of A to Z, okay. Actually, ASCII stands for American Standard Code for Information Interchange. So we have to take note of this because we'll be using this for assigning the characters to communicate with our Arduino microcontroller. Okay, so I'll be explaining it later on. So for our letter A, for the first character, will be if we type A on our serial monitor, or let's say our LCD, when A is pressed or when A is typed, then we'll be having the motor rotate clockwise. Okay, when it will rotate clockwise. So from low here to high. So we'll be showing it later on, or I mean, let's show it already here. But let me first explain. So this, when we type A, okay, let's start the simulation. So, okay, when we type A on our LCD, okay, as you can see, 65 appeared on the serial monitor or on our LCD, and our motor rotates clockwise. Okay, clockwise. Because why 65? Because based on the ASCII binary characters here, the capital A, 65 is the assigned number for that. Okay, so our code is correct. Then let's have the second task, which is to rotate it counterclockwise when B is pressed. So let's type B. Okay, wait, let's stop it first. Okay, so let's type B. Okay, so let's enter. Wait a moment. So let's enter it. Okay, as you can see, our motor here is rotating counterclockwise. Okay, counterclockwise compared to letter A. So let's type C again. Wait a moment. Let me show you the letter A first on a zoom perspective. So let's type A. Okay, it rotated clockwise, and then let's type C. Okay, let's type B again. It rotated counterclockwise. So why is 66 appeared on the serial monitor screen? Because when we type capital B, 66 is the assigned ASCII value for that. Okay, so now last task is when you type capital C, it will stop. So is that right? Okay, so when we type capital C, the motor stopped. So with this, 67 appeared on the screen on the serial monitor? Why? Because 67 is assigned for capital letter C for the ASCII binary character table. So this proves that our program is correct, okay? And our connection on our breadboard is correct as well. So that concludes our first part for the experiment. So let's stop the simulation. Okay, so after having a successful code, okay, so we'll be pasting our programming codes here on our Word file. So for our task number 2, we have to create a program that will control the speed of the motor by controlling the pulse width of the microcontroller, meaning this is PWM or pulse width modulation. So this can be done using potentiometer, okay, if you have actual electronic components. So the width of the pulse depends on the sent integer to the microcontroller, ranging from 0 to 255. So sending 0 will cause the speed of the motor to the slowest, okay, so the rotation of the motor will stop, and then sending 255 will cause the speed of the motor to the fastest. So it's so fast now. Fastest. So let's have our code here. So we already have our code here, so I've already finished it. So again, same with the first code, we will be defining the pins, okay, the enabling pin and the input pins from our Arduino. And then here we'll be declaring characters for our motor control. Okay, we'll be controlling the motor speed using string characters for the meantime, using to rely it on our Arduino microcontroller. So next one will be integer. We have to declare the integer value for our motor speed. Okay, so because when we say string, it's a series of characters, but when we say integer, it's a specific value of numbers, right? If you can still remember on your comprog subject. So we'll be setting pin number 1 as our pin number 1, 2 and 7 as our output, and again we'll be initializing our serial monitor. So here on this part, we'll be assigning the motor direction. Okay, so we'll be assigning here a clockwise direction, because on this task we are only asked to control the speed of the motor. So we'll be having a clockwise direction as our condition. Then on this part of our program, okay, wait a moment, let's adjust it. So in this part of our program, we'll be controlling the speed of our motor using our strings and our integer value. So let's have here our if serial variable statement or code here, and then below that we'll be having motor control, and this motor control value, our serial monitor will be reading its character, okay, or basically it will get the input from our serial monitor, meaning it will get the input from our LCD. If it's actual, it will get the type or encoded input from the LCD, and then there's an else statement wherein we have your motor speed, wherein we will be converting the string character to an integer character. Okay, why do we need that? Because let's say, for example, under this if statement, if we will not be considering an else statement, let's say, for example, we'll be typing names, okay? We'll be typing letters instead of 0 to 255 or instead of integers. Then there's a possibility that the motor will still rotate, okay? Because we didn't put an else statement here. So this else statement will help us, okay? Will help us convert the string character to integer, meaning limiting the data or the character that will be understood by the microcontroller, limiting it to only integers, okay? Because that's the requirement, from 0 to 255, okay? So meaning, if you're going to type your name there, let's say, for example, Rika, okay? Let's type there, Rika. If you're going to type Rika there, the motor will not rotate. So that's the purpose of the else statement. So we have here analog write. So we'll be having this code to run the motor with the speed based on our serial monitor input. So this will get the information on what number did you type on our LCD, on our serial monitor. Is it 0? Is it 100? Or is it 255? Okay, it will analyze it. And then for this one, we'll be having an input. This is only a label, so people will not be confused where to type. Okay, where to type the integer. So that's why we have here input number for motor speed. Okay, that's the goal of that. Then we'll have here serial print in. So motor speed. So it will be showing. Okay, it will be showing the motor. I mean, the integer that you've input on the serial monitor on your LCD. And then after that, the Arduino microcontroller will be reading what you've typed, okay, and will be mapping the motor speed. So 0, okay, 0 as 0%, okay, meaning the motor is stopped or not rotating, and 255 as the fastest or the 100% speed of the motor rotation. So that's the logic behind this code. So using this code, we'll be mapping value of speed from 0 as lowest to 255 as the highest. So with that, let's run our simulation. Okay, let's wait for it. So as you can see, on our serial monitor, there is a continuous display used because of this code, input number for motor speed. So let's have 100. Okay, 100. Let's type 100 there. Okay, as you can see, our motor here rotated. Okay, but not so fast because we only type 100. 255 is the highest. So let's type 10. Okay, if you can observe, the rotation slowed down when we encoded 10. So let's encode the 0. Okay, as you can see, the rotation of the motor stopped when we encoded 0. So let's encode 200. Okay, as you can see, when we type 200, the motor rotated again. Then let's type 50. Observe the motor properly, okay? I mean, yep. From 200 to 50. Okay, see, the rotation of the motor slowed down. So from 50, let's encode 255, which is the fastest, or the 100% of the motor rotation. Okay, as you can see, the rotation of the motor increased. Okay, the rotation speed of the motor increased. And lastly, let's make it stop. Okay, so as we input integer values from 0 to 100, the motor rotation speed can be controlled. So let's type Rika. Let's say, for example, Rika. Okay, as you can see, the motor did not rotate when we type any values. Okay, let's type, let's say, any characters. Okay, let's say robotics. We'll be typing robotics there, which is not an integer value. The motor will not rotate as well. Okay, let's type there ECE. Okay, again, the motor will not rotate. So that's the purpose of our else statement here. So this experiment is very helpful. We have already our conclusion. So this experiment is very helpful for projects which involves control, okay, control of our DC motors, let's say for our electric fans, okay, for our electronic appliances that involves DC motor as your electronic components. This is also helpful in terms of applications in industries and machineries which involves direction of the motor, let's say in our submarines, in our ships, and in our mechanical engineering, okay, mechanical engineering topics and projects as well. So this experiment is very helpful. So knowledge about programming our DC motors is really beneficial and significant for us as future electronics engineers. So again, our last step is you input your code here, okay, after a successful simulation. And then let's have here the schematic. This will be our schematic, and this will be our circuit assembly, okay, using our fritzing. Okay, and then we have here our working sketch, okay. We have here our working sketch in TinkerCad. So with that, we're done with our experiment number 1. And I hope you learned something. I mean, you learned a lot from our experiment. Again, my name is Exp1 from ECE1, and I hope I'll be seeing you in our next experiments. Bye!